I'm Anil Kumar, and in this video we will try to model a real life situation with the help of trigonometric function. The question here is, Jason is riding a bike home one day and picks up a nail in his wheel which has radius of 60 centimeter. As the wheel rolls, the nail moves in a circular motion. Assume that the nail starts rolling at its lowest point. Determine a sine equation of the sinusoidal function that describes the height of the nail from the ground in terms of distance the wheel rotates. Now in this question mark two things. First is that we have to write the sine equation. The second is the nail starts from the ground, right? So it's kind of like this. Let's say that's the wheel. And on the wheel, while riding, the nail gets stuck here, right? So this is the wheel which has radius of 60. So as the nail gets stuck here, it moves along the wheel upwards. So that will result into a sinusoidal function which will be kind of like this, where this is the height of the function of the nail at any instance of time. Now the question here is, assume that the nail starts rolling at its lowest point, so that's the starting point for us. Determine a sine equation of the sinusoidal function that describes the height of the nail from the ground in terms of distance. In terms of distance, the wheel rotates, right? Not the time, distance. So what is the distance in this case? Now distance is along. Now as the wheel rotates like this, so horizontally, that is the distance. Do you see that? Now this distance is same as the circumference. After one full cycle, it repeats. That means if you are considering these 2 points, then these 2 points are one circumference away. And we have to write our sinusoidal function in terms of that distance. So that is the question before us, right? I hope the question is now absolutely clear, right? So what we have here is height of the nail as a function of distance d, and on this side we have distance. Let us say distance is in centimeters, since we are given radius in centimeters. Now let us try to develop the model, a sinusoidal model for this particular sinusoidal wave, right? So what we have here is kind of axis. So this is the axis. And that should be the maximum, correct? So that is the maximum. And this is the minimum value. From the graph, you can see from this situation or that 0 will be your minimum. Since 60 is the radius, so the axis will be at 60 and maximum will be plus 60, right? So diameter. So 60 plus 60 is 120. So 120 is going to be the maximum. What is going to be repeating distance? That is what we need to find, and we are calling that as capital T. The time when it repeats or the distance when it repeats, right? So let me use T itself, which is equals to 2 pi r. It repeats after one full circle. Now in this case, r is 60 for us. So we'll write 60. So we have T as 120 pi. It is in centimeters. Once you know T, you can find the value of K of your sinusoidal function, which if you are doing in radians, which we would like to do, is 2 pi by T, right? So which will be 2 pi by 120 pi, or pi and pi cancel, we get 1 over 60. Okay, so that becomes the K value for a sinusoidal function. Now when I'm saying sinusoidal function, we want to write equation in the term of h is our height in terms of distance, a times sine of k, distance d minus phase shift, let me write p for phase shift, plus axis, which I am writing as c. Okay. Now in this particular case, we have a, the amplitude, as the radius. So we know a equals to the radius, right, of this wheel, that is 60 centimeters. The axis is 60 and C is also equals to 60 centimeters for us, the axis. To find P, what can we do? Now sine wave starts from that point, the point on the axis from where the wave is rising. Now always this point is quarter of a cycle away. So what we found here is that the time is 120 pi. This is 1, right? So this is half of 120 pi, or that will be 60 pi, half of this. And this point will be half of that, which is 30 pi. Do you see? A quarter of the cycle. So phase shift P in this case is T over 4, quarter of the cycle away, right? Which is 120 pi over 4, which is 30 pi. Do you see that? Now putting all the things together, we can write our sine equation, which is height in centimeters is equals to amplitude is 60 for us, the radius, sine of k is 1 over 60, distance d in centimeters, minus phase shift of 30 pi, plus 60 the axis, right? Now in this particular case, d is in centimeters, right? So h of d is in centimeters also, right? So those are the units, and that's the equation. I hope with this you clearly understand the steps in which this kind of question should be done, and I hope that helps. Thank you and all the best.